Welcome to another episode of Software Explorations, Concepts and Overviews, hosted by yours truly, Tech Coach Ralph, where we are engineered to win. In today's episode of Software Explorations, we are going to be going over GraphQL, thanks to my tech barbarian, Bridget, who reminded me that she asked me, like, hey, are you familiar with GraphQL? And I said, you know what? I am not familiar with GraphQL. I hear about it all the time, and it has been on my list to investigate, to explore, to find out more about. Because one, we definitely use it at my job, and two, we were talking about APIs these past few weeks, and this would be a great opportunity to learn more about GraphQL, what it is, how it works, why was it even invented, why, like, where did it come from, So that's what we're going to explore. That's what we're going to investigate. So without any further ado, let's just jump right into GraphQL. Like I said, the topic is GraphQL, introduction to GraphQL. This is going to be a even longer one than usual because there is a lot of information to cover. I am not familiar with GraphQL at all, so we are going to dive deep into it together, and then eventually we will do a live stream where we are figuring out how does it work, how to implement it, how can we test it. All right, so let's just go and do it. Let's go and do it. All right. All right. So our agenda for today, we're going to have a quick recap of what, of like APIs, and then we're going to find out what GraphQL is. We're going to talk about why does GraphQL matter, the key concepts of GraphQL, how does GraphQL line up against REST, and then the benefits of using GraphQL, some use cases, some challenges, talk about implementation of GraphQL, and then we're going to wrap it up with our conclusion. So quick recap of APIs. The past few weeks, we've been talking about different types of APIs, what APIs are, application programming interface, how to test them, how to automate them. And we've been going on the live streams on actually, doing some automation. Like this past Thursday, we wrapped up doing automation with Java. And rest assured, before that, we did Python and their Quest library. So that is so that's pretty much what we've been doing on APIs for the past few weeks. And now today we're going to be talking about GraphQL. So what exactly is GraphQL? GraphQL is a query language for APIs and server-side runtime for executing those queries. GraphQL was developed by Facebook in 2012 to address the limitations of RESTful APIs, and it was publicly released as an open source project in 2015. So you gotta love the tech community. Facebook figured out how to make it address the limitation that they were having, and then they released it to the public as open source so anyone can partake in that technology. All right, so what are the limitations of REST? So we've been working on REST these past few weeks. But however, there are some limitations which GraphQL looks to address. So overfetching and underfetching, and we'll talk more about exactly what that is later on. So there's versioning challenges, fixed endpoints, limited query flexibility, redundant data transfer, lack of strong typing, statelessness, handling complex relationships, caching complications, and scalability and resource coupling. So those are some of the limitations of REST. We might not know exactly what all of them mean, but we know that they are challenges with using RESTful APIs, and GraphQL is looking to address all of these limitations. So let's dive in. So why does GraphQL matter? So overall, GraphQL's importance in modern web development stems from its flexibility, efficiency, and ability to address many of the limitations associated with traditional RESTful APIs. Its unique approach to API design enables developers to create robust, scalable, and maintainable applications, aligning well with the demands of contemporary development practices. All right, so sounds pretty important, but let's find out more. Modern web development. So modern web development is client-centric data fetching, having a reduced over and under fetching, simplified API evolution, strong typing and schema definition, having a single endpoint. So these are all the ways that GraphQL helps with modern web development, all right? It supports complex relationships, development tools, and ecosystems. It has an improved developer productivity, optimized for modern applications, and the adoption and community support. So this is how GraphQL revolutionizes modern web development. So understanding GraphQL, right? We're going to go over the key concepts, which would be the schema, type, queries, mutations, resolvers, and the GraphQL playground. And then we're going to be looking at a little bit of a comparison between GraphQL and REST, which we're going to cover like the request structure, data retrieval efficiency, and over and under fetch. So over and under fetching, as we mentioned previously, we're going to look a little bit deeper into that. So the schema. The schema is the central definition of the GraphQL API. It describes the type of data available, their relationships, and the operations, queries, and mutations that can be performed. Schemas are strongly typed, ensuring consistency and validation. So the types. Object types represent entities with fields and relationships to other types. Scalar types represent basic data types like integers, floats, strings, booleans, and IDs. Enum types represents a set of named values allowing you to constrain input to specific options. So thinking about the Tech Barbarians app that we're building, Pooey Pants app, I could easily see implementing some of this GraphQL stuff. So that might be an idea for the future. Might have to throw that onto the backlog, moving over from our REST API implementation to a GraphQL possibly, all right? So in addition to more types, right, we have union and interface types allow for polymorphic relationships between types, enabling more flexible data modeling. List and non-null modifiers defines whether a field can contain multiple values, a list, or if it's required, not null. So like you can't have a missing field or something like that. So queries. Queries are operations used to fetch data from the GraphQL server. A query defines which fields to retrieve and can include nested relationships to fetch related data in a single operation. Queries are sent from the client to the GraphQL server, and the server responds with the requested data. Very similar. That part is very similar to REST APIs, where you'd send your query to the endpoint, and then you're going to get returned the data that you requested. Mutations. So mutations are operations used to create, update, and delete data on the server. They are similar to queries, but are intended to modify the data state. Mutations can also return data, allowing clients to receive updated information after making changes. Right? So next up is the resolver. Resolvers are functions that define how data is fetched or computed for a given field in the schema. They connect the schema with the underlying data source, such as databases or external services. Resolvers can be synchronous or asynchronous, depending on the data source's nature. Next up, GraphQL endpoint. A GraphQL server typically has a single endpoint that accepts both queries and mutations. Clients send their requests to this endpoint, and the server processes them based on the schema and resolvers. Next up, the GraphQL playground, GraphQL. These are interactive development tools that allow developers to explore a GraphQL schema, write and execute queries, and visualize the responses. They are valuable for testing and debugging during development. So sounds like they have a good way to implement and test things out before we get into production. So that's always helpful. And I would be looking to see how do we automate this type of testing? What are some GraphQL automated tests that we can implement? So fragments. Fragments allow for reusability with queries and mutations. They enable developers to define reusable pieces of query logic, reducing redundancy and improving maintainability. Now, directives. Directives are special instructions in GraphQL that can alter the behavior of queries, mutations, or schema elements. Common directives include include, skip, and custom directives for more advanced functionality. Subscriptions. Subscriptions allow clients to receive real-time updates from the GraphQL server. They are typically used for live data such as chat applications or live notifications, enabling a more interactive user experience. Okay, so like when you have like the chats that are happening or live data like scores and things like that, those could be being sent to you towards through subscriptions in the GraphQL server. Request structure. So GraphQL uses a simple and flexible request structure that allows clients to specify their data requirements in a concise and expressive way. This structure is designed to support a wide range of operations, including fetching data, updating data, and receiving real-time updates. Endpoint. A GraphQL server typically exposes a single endpoint, usually a URL where all GraphQL requests are sent. The endpoint is used for all types of GraphQL operations, including queries, mutations, and subscriptions. HTTP method. GraphQL requests are commonly sent using the HTTP post method, although the HTTP GET method can also be used for certain read-only operations like introspection queries. The post method is preferred because it allows clients to send complex query structures in the request body. So the request body contains the query, the GraphQL query, or mutation to be executed. This can contain nested fields, aliases, fragments, and directives. It also has variables, a key value map of variables used in the query. This allows clients to dynamically pass data to the query without modifying the query string itself. The request body also contains the operation name, an optional string specifying the name of the operation being executed. This is useful when a request contains multiple operations, like a combination of queries and mutations, to indicate which operation to execute. Next up, the headers. It has authentication to send tokens or credentials for authorization. Content type, usually set to application/JSON to indicate that the request body contains JSON data. Other custom headers for additional metadata or request-specific information. So this part is like very similar to REST as well. And I mean, when you're trying to enhance something, you're not going to go totally away from it to build something totally new. You're just going to be, building upon it to make it better. So query structure. The query structure contains operation type, specifies whether the operation is a query, mutation, or a subscription. The field selection, a list of fields to be retrieved or modified with optional nested relationships. Arguments, parameters passed to specific fields to control data retrieval or mutations. The query structure also contains aliases, custom names for fields or results, allowing clients to handle multiple fields with the same name. It also contains fragments, reusable pieces of query logic, which can be included in multiple queries or mutations, and directives, special instructions for conditionally including or excluding fields based on certain conditions. So subscriptions. Subscriptions are special types of GraphQL operations that enable clients to receive real-time updates. While the request structure is similar to other operations, subscriptions often require additional setup, for example, using WebSockets to establish a continuous connection for real-time data. So what is the data retrieval efficiency with when you're comparing GraphQL and REST, right? So data retrieval efficiency in GraphQL refers to its ability to minimize unnecessary data transfer and optimize how data is fetched from the server. This efficiency is one of the core reasons of GraphQL's popularity, particularly in modern web and mobile development where bandwidth and responsiveness are crucial, which makes a lot of sense, right? If we can reduce the information that we're returning or that we have to send, that's going to make it a lot more efficient and faster, when we're getting our data back. So over and underfetching. So overfetching and underfetching are terms used to describe inefficiencies in data retrieval from an API. GraphQL can help address both overfetching and underfetching through its flexible query system. So we're going to dig deep into what overfetching is and what underfetching is. So first up, overfetching. Overfetching occurs when an API returns more data than the client actually needs. This leads to an unnecessary data transfer, increased bandwidth usage, and potentially slower response times. In RESTful APIs, overfetching often happens because each endpoint represents a resource with a fixed structure, so clients get everything the endpoint provides, even if they only need a subset. So overfetching in REST. Imagine you have a REST endpoint /users that returns user details, including their posts and comments. If a client only wants basic user information like name and email, they still receive all of the extra data about posts and comments, leading to overfetching. So how does GraphQL solve this overfetching issue, right? GraphQL allows clients to request exactly the data they need, reducing overfetching. Clients specify the fields they want in a query, and the server returns only those fields. This fine-grained control helps minimize unnecessary data transfer. So here's an example in GraphQL. So for user ID 1, you just want to get the name and the email back. The query retrieves only the name and the email, avoiding unnecessary data retrieval. Next up, underfetching. Underfetching occurs when an API returns less data than the client needs, requiring additional requests to fetch the missing information. This can lead to an increased round in trips to the server, reduced performance, and more complex client-side code. So you have to do a bunch of work. You have to do a bunch of requests just to get a particular piece of data. So let's find out how this works in REST, right? So using the previous REST example, if you want the user's information along with their recent posts, you might have to make separate requests to /users for the user details, and then to /users/ID for the posts for their post for their post. This leads to multiple network requests and increased complexity. So how does GraphQL solve this problem? GraphQL allows clients to retrieve related data in a single query, reducing underfetching. Clients can include nested fields in their queries, fetching multiple pieces of related information simultaneously. So the example in GraphQL. So we have the user ID. We say we want the name, we want the email, and then you go to post and you say, I want the title and the content. The query retrieves the user's basic information and their post in one request, avoiding underfetching. So that is awesome. So what are some of the benefits of GraphQL then? After reading all that and see how it is, better, I guess, than REST, what are the benefits of GraphQL? So it has flexibility. Clients request exactly what they need, right? They don't get everything back, and they can get, or they don't get less than what they need. They can get exactly what they're looking for. Has better performance. It reduces data transfer by preventing overfetching. Strong typing, clear and robust schema definitions. Benefits of Graph. So more benefits, right? Simplified versioning, ability to evolve without breaking clients, developer productivity. It has the tools and the community support. So let's get into some use cases and examples. So we can see examples which we'll look into a little bit deeper from social media platforms. Facebook, the ones who created GraphQL, that's a definitely real world example. E-commerce, how you can customize client experiences. Mobile applications, how you can optimize bandwidth and data transfer. And let's just dive deep into a few of them. There's so many different use cases for it, but let's take a look at some. So the social media example. In social media apps, users typically need a personalized feed containing posts, comments, likes, and user profiles. GraphQL allows clients to request exactly what they need in a single query, reducing the number of requests and the volume of transferred data. For example, a client can fetch a list of posts with specific details along with the user information for the author and the counts of likes all in one query. So you don't have to do a query to the post where you're getting the likes, a query to the user information where you're getting the name, all that type of stuff. You can just, and then you also have to see a query of who exactly liked it, right? So if you're thinking about Facebook, you can see who likes something. So you can do all in one query, and then that's going to populate that particular post or whatever it is that you are querying for. So in e-commerce platforms often require complex data relationships such as a product, category, review, and user profiles. With GraphQL, developers can build flexible product pages where the client retrieves detailed product information, related products, user reviews, and current inventory in just one request. So we are preventing a bunch of different requests into one, and that makes it a lot faster and a lot more efficient. This approach simplifies the client-side code and improves performance by reducing HTTP requests. So by the client-side code, right? When you're developing this, if you don't have this GraphQL where you can do like one request and then you get all the data you need, you're gonna have to do a request to the user information, a request to the product API, a request and then find the related products and populate that. With this, you just do one request. Say like, I don't know what the endpoint would be, but like let's say / product or user or whatever, and then it just it's like magic. It populates all the fields. And we are going to be diving into this in some upcoming live stream to see, okay, how can we make this work? How can we get more familiar with it? How can we test it? Right? And one more example is mobile applications. Mobile apps need to minimize data transfer to save bandwidth and improve performance. Because on the mobile, it's usually slower than if you have the really fast broadband at home or cable internet or fiber or whatever you might have. GraphQL's ability to avoid overfetching is valuable in this context. For example, a mobile app for a travel company can fetch a list of destinations along with limited details for each while providing an option to fetch more information on demand. This flexibility helps optimize the user's experience on the mobile device. Like speed is key. Speed is key. Right? So what are some of the challenges though? Because as good as it might sound, there has to be some challenges. It can't be too good to be true, So what are the challenges with GraphQL? So number one, there is a learning curve, which I can see coming from a mile away We're going to have to figure this thing out. But guess what? We love learning curves over here, right? We adore them. We're going to go and we're going to figure it out. And then the complex query structures, having to figure out how to do the queries, it's a security risk. The caching challenges, the tooling in the ecosystem, maturity, server-side complexity, performance bottlenecks, schema evolution and maintenance, and then there's rate limiting and monitoring, and then the compatibility with existing systems. So these are all the things that can be challenging with GraphQL. But I'm sure with it being like fairly new, open source for the past almost 10 years, being developed in 2012 by Facebook, there's going to be some growing pains, but I'm sure everything is overcomable. Right. So let's talk about implementing GraphQL. And this is what we'll be doing on a live stream. Well, we're going to have to set up a GraphQL server. Common frameworks are Apollo Server, Express.js, and some other ones. We will probably be using Express, either Express or Python, one of them. But Express is what I've been using for the Poopy Pants application for my tech barbarians. So we might just continue with Express, right? Writing the schema and the resolvers, example, simple user schema and query. And we'll probably find some type of tutorial or documentation to follow to do that. Connecting to a front end. So example, Apollo client is a front end. I'm not familiar with Apollo client, but we'll figure it out. And then security considerations, rate limiting, authentication, and authorization. So we'll figure out how all that works because we might just be doing a quick little demo project. We might not even get to the rate limiting and stuff like that, but we'll figure it out. We shall figure it out. All right, so that's it for today, right? Let's wrap it up. We talked about today, what exactly is GraphQL? Why does GraphQL matter? The key concepts of GraphQL. We did a brief comparison of GraphQL versus REST, the benefits of using GraphQL. We looked at some use cases. We talked about the challenges, and then we talked about how we're going to implement it once we get to the live stream about it. So that is about it for today. Let's go back to full screen. And there you have it. That is GraphQL in a nutshell. A lot of information. It was a lot of information, but it was well worth it. I certainly learned a lot, and I can't wait to get to the live stream we're going to be working on. It's probably going to be a few weeks away, but stay tuned for it. We're going to make it happen. I'm excited about it. I hope you are. Let me know what you thought. Let me know what you think. Are you familiar with GraphQL? That's my question to you. Are you familiar with GraphQL? If you are, leave me a comment. I'm pretty sure I got some things wrong, but hey, we're learning. This is totally foreign to me. I'm learning. You're learning. Maybe you're not. Maybe you already know this like the back of your hand. And if you do, let me know. Reach out to me. Did I get something wrong? Do I need to make a part 2? Do I need to update anything? Let me know. I'm here to serve you. I am here to serve you. I want to see you win, as always, right? So if it's through GraphQL that's going to help us level up, then let's go ahead and do it. Let's go ahead and do it. But I'm going to wrap it up. So if you haven't done so already before you get out of here, do me a big, big favor from the bottom of my heart. Go ahead and like the video, share the video, subscribe to the channel, hit the notification bell so you can know every single time that we go live. And if you need additional coaching and additional exclusive content, go over to www.techcoachralph.dev where you can sign up for access to the Patreon, right? And you can sign up to one-on-one coaching with me. Spots are very, very limited, so we shall see. If you want to level up, you know where to go, all right? But until then, that's it for today. Thank you so much for tuning in. This is Tech Coach Ralph, and we are out.
If you enjoyed the fascinating information shared in this video and you want more, be sure to hit the subscribe button to Tech Coach Ralph to be notified for new videos.